17, I think. If I'm wrong, someone correct me. There's been so many. Okay, lecture 17. Underline that. Absolute value inequalities. Okay, so when we talk about inequalities, we basically mean things that are not equal. That's what inequalities mean. So inequality, let's just write a definition. How about that? Inequality. An inequality is a relationship between two expressions, between two unequal expressions. But sometimes they are equal, and we'll talk about that. So when I mean inequalities, I mean things like greater than, less than, greater than or equal to, less than or equal to. So let's talk about the symbols really quick. So there is the less than. Notice how it's pointing to the left, right? To the left, or is that my left? Anyways, left is less than, and we have less than or equal to, which is basically a less than sign, but with a little line drawn underneath it. So this is less than or equal to. Okay, that's what that little line underneath means. And then we got the greater than symbol, right? Greater than is kind of like the less than symbol, but I just reverse it. So now it's pointing to the right. So this is greater than. And then last but not least, greater than or equal to, which is this. Greater than or equal to. Okay, and those are all the symbols that I got. Okay, let me flip to the page and we'll start talking about inequalities. Okay, let's talk about the two different symbols. So for this class, we're going to be considering these two to have the same strategy. So I'm going to group these two together, the less than and the less than or equal to. And we're also going to group the greater than and greater than or equal to, because they're going to have the same strategy. So these are going to have the same strategy. And I'll show you what that is in a second. So same strategy here and same strategy here. Okay, so those are the four symbols that you'll see. Okay, so if we have a less than, let me put a star beside this. If you have a less than, which could be this or this, then you're going to use the word and. You're going to use the word and. And you'll see what that means in a second when we start going over examples of how this is done. But basically all you need to know is if you see a less than symbol, whether it's the less than or it's the less than or equal to, you're going to be using the word and. So let me underline that. You're going to be using the word and. So then we're going to talk about the strategy for the greater than symbol. So let's talk about that. If you see the greater than symbol, which is basically this and this, you're going to be using the word or. And once again, you'll see what that is when we talk about it. But basically, just know that the less than means you're going to use and And the greater than means you're going to use the word or. And you'll see what I'm talking about once we get to the first few examples of these. Okay? Let me move my paper up a little bit. All right. So the next thing I want to talk about is how we're going to write our solutions. So when we talked about equations on Monday, notice how we kept the left side the same, but the right side is going to switch signs. So we had it set equal to a positive number. And then the second solution was when we set it equal to a negative number, right? Well, we kind of got the same strategy going on for these. We're going to have a first solution, and we're always going to have a second solution. So let's talk about those. So the first solution, we're going to keep everything the same. So we're going to keep signs the same. It's that simple. We're going to keep everything the same. So that's for the first solution. That's what we're always going to do when we break it up into our two solutions. And for the second solution, we're going to switch the inequality sign and the number sign. So let's talk about that. The second solution, we're going to be switching two signs. We're going to be switching the inequality sign and the number sign. And the number sign. So let me underline those. And then I'll let you copy it down. There we go. Okay. So just like when we did equations, you're going to have two different solutions. And that's because absolute value allows for two different solutions every single time. For the first solution, you're going to be keeping everything the same. But for the second solution, you're going to be switching the inequality sign. The inequality sign is either going to be a less than or equal to, a greater than or equal to. And when I say switch, that basically means if it's a less than, you switch it to a greater than. If it's a greater than, you're going to switch it back to a less than. That's what I mean by switching the inequality sign. But you also have to switch the number sign, right? The number sign. So when I say number sign, I really just mean positives and negatives. So if I give you a positive, you're going to switch it to being a negative. And if it's a negative, you switch it back to being a positive. So it's like you're switching two different things, and you got to remember that. Okay? So let's see how that works in action. Let's do an example. Okay. Absolute value of x plus 3 is less than 7. Okay. So let me slide it on down a little bit. There we go. So first of all, notice that we have absolute value symbols. And that's these vertical lines right here. That just means absolute value. And whenever I say it, I just say absolute value of whatever's on the inside of it, right? The absolute value of x plus 3 is less than 7, right? That's the less than symbol. So what we're going to be doing is we're going to be breaking it up into two different solutions. So I'm going to have my first solution over here, and I'm going to have my second solution over here. And we'll talk about the differences between those. Okay? So for the first solution, remember, we keep everything the same. That's what I mean by keep all the signs the same. So I'm going to take the x plus 3 out of the absolute value, just like you see it right here. I'm going to take it down. Just taking it right outside of the absolute value symbol, just like that. So I take it out, and I keep everything the same. So the less than is going to stay the same. That just comes down. And the 7 stays the same. Remember, that's a positive 7, right? And I got to keep it positive because we're keeping everything the same just for the first solution, okay? So x plus 3 is less than 7. Now, let's talk about the second solution. Remember when I said we have to switch both signs? What's that going to look like? Well, the x plus 3 is going to stay the same. The x plus 3 is going to stay the same. But I'm going to be switching the less than to being a greater than, right? So this is actually going to switch to being a greater than, okay? So we've just switched what? The inequality sign. We just switched that. And then we switched the number sign. So remember how it was a positive 7 when we started off? Now it's going to be a negative 7, right? So I'm going to have a negative 7 right here. And then I'm going to solve both for x, just like I would do any equation, right? So to get x by itself, what would I have to do? I would have to do what? I got to get rid of this plus 3, right? So how do I get rid of a plus 3? I do the opposite of plus 3, which is subtracting 3 from both sides. So I'm going to subtract 3 from both sides. And I'm going to do the same thing over here too. And we'll see what we get. Okay, so on the left side, the plus 3 and the negative 3 are going to cancel each other out. So I only have an x. I have my less than symbol. That hasn't changed, right? And then 7 minus 3 is what? 4. So x is less than 4. That's going to be my first solution, okay? X is less than 4. So what about my second solution? What's that going to look like? Well, it's pretty much the same thing on the left side because the plus 3 and the minus 3 are going to cancel each other out. So the x is going to come down. The greater than symbol is going to come down. And then what's negative 7 minus 3? Negative 7 minus 3. That's going to be negative 10. Negative 10. Done. Okay. So my first solution is x is less than 4. And my second solution is x is greater than negative 10. Okay? Now, remember when we talked about the and the or up here? So look up here. See where my pen is? Look up here. Remember when we did those stars and we said less than we use and, greater than we use or? Well, what did we start off with in the problem? What did we start off with in the problem? We started off with a less than symbol, right? So what word are we going to use? Are we going to use the and or are we going to use the or? Which one do you think we're going to use since we started off with a less than symbol? Are we going to use the and or are we going to use the or? Well, since it's a less than, we're going to use the and, right? So I'm going to use and. The and comes down. And I'll underline that so you can see it. Okay. So we have two different solutions for every single inequality. X is less than 4 and x is greater than negative 10. So the last thing we want to do is we want to draw a number line and show our answer on a number line. So here's how we do it. I draw my number line and I'm not going to use a ruler, so I hope I don't mess up. But let's say we have a number line. Okay, that's good enough. And what I'm going to do is I'm going to put the capital R over to the right side. That just stands for real numbers, right? Every single real number in the universe lives on this line somewhere, right? And I'm going to put 0 in the center. Well, actually, I'll probably put it over here a little bit. So I put down my 0, and then I'm going to take the numbers that I found, and I'm going to put it on the number line, right? So I've got a 4. I could put that right here. 4. And then I have what? a negative 10. I'm going to put that on the number line too. So the negative 10 can probably go way down here. Negative 10. Okay, I got my number line. Okay, so now how do we graph this? Now, do you remember when you did graphing inequalities where if you have a less than or greater than, you have the open circles? Let me write that down. So if you have a less than or greater than, you're going to use open dots or open circles. But if you have the less than or equal to and the greater than or equal to, you're going to use the closed dots. Okay. So what I'm going to do is I'm going to use the open dots. I'm going to put an open dot at 4. Put that open dot right here. And the negative 10, I'm going to put the open dot on that. Okay, so which way do we shade? Well, what does the first solution say? The first solution says x is less than 4. So I have to shade to the less than 4. That means everything to the left of 4, it's got to be less than 4, right? So I'm going to shade to the left of the 4, right? But what does the second solution say? X is greater than negative 10. So I have to shade to the right of negative 10. And then what's going to happen is the shading is going to meet in the middle. So it's going to look like this. There we go. And that's it. We just shaded the number line. I don't like to use the really heavy shading that some people use. I just like to kind of draw it that way. I think it's kind of cleaner that way a little bit. And you can really see what kinds of numbers are part of the solution set. Because any number in between negative 10 and 4 can work, right? I can't choose 5 for my answer because that's well outside of the shade, right? And I can't choose negative 20 down here, right? Because that's outside of the shading. So we can choose any number between negative 10 and 4. You know, for example, 0. 0 would be an answer for this. And in fact, there's infinitely many answers you can choose. But you just shade the number line accordingly to whatever solutions that you have, okay? We're gonna do a couple more examples of these just so you can get it, and then we'll call it a day after that. Okay. Yeah, we'll probably do 2 more examples. So I'll give you some time to copy this, and then I'll change the paper. So inequalities, they're always going to have 2 solutions. You keep the signs the same, and then for the second solution, you switch all the signs. So that's pretty much all you need to remember. Okay. Let me get my next example ready. Okay, so the next example is going to be pretty much the same, but I'm going to use a greater than or equal to symbol. And you'll see what I mean when I put it up there. One thing I'll say about this before we move on, when you have the and symbol, they're always going to meet in the middle. Like, I'll write solutions converge. The solutions converge or meet in the middle. So that's what the solutions are doing. They're meeting in the middle. And for the next example that we do, you'll see what happens when they diverge, or they go in opposite directions, basically. But this is always true for the and symbol. For the or symbol, you'll have to wait and see for the next example. Okay. Okay. Let's try this one. Okay, same basic setup. We got the absolute value of x plus 3 is greater than or equal to 7. So let's break it up into our two solutions. My first solution is going to be over here, and my second solution is going to be over here. So for the first solution, I want to keep everything the same, every single thing. So the x plus 3 is going to stay the same. The greater than or equal to, that's going to stay the same. And the 7 is going to stay the same. Everything stays the same. So that's the first solution. Everything is going to stay the same. And then for the second solution, things are going to start switching up. But the x plus 3 is going to stay the same. So x plus 3. And then I'm going to switch the inequality sign to less than or equal to. So the inequality sign is going to flip. And the 7 is not going to be positive anymore. It's going to be a -7 now. -7. Okay. So that's basically what our two solutions are. I keep everything the same over here. And then over here, I switch everything, right? I switch the sign. I basically just turn it around. And then for the number, that's going to go from either negative back to positive or from positive back to negative. So I'm switching both signs. So let's solve them both. I subtract 3 on both sides. Subtract 3 on both sides. And let's see what happens. Okay. So when I do that, I get x is greater than or equal to 4. So that's my first solution. X is greater than or equal to 4. And then over here, what happens? The x comes down. I have less than or equal to. And then what's -7 minus 3? Well, just like last time, that's going to be -10. Okay, so I got my two solutions. And last time, remember how I used an and? This time, I'm going to use the or. So I'm going to put an or right here. So my answer is going to be x is greater than or equal to 4, or x is less than or equal to -10. Okay? So let's see what that looks like on a number line. Draw my number line. I got my capital R over here. And I put the 0 kind of over here. I put my 4 down. And then the -10 can go over here. Okay. So now I've got my number line, and I'm ready to put my dots down. Now, since I have the greater than or equal to and the less than or equal to, I'm going to be using closed dots. Closed dots. Because these symbols are going to actually include the numbers that I'm talking about. So Let's put a closed dot on 4 and -10. And I'll make them kind of big so you can see them. Okay, so those are my closed dots. Okay, now let's think about which way we're going to shade. Which way are we going to shade? Well, for the 4, which way are we shading? X is greater than or equal to 4, right? So greater than means we shade to the right. Or is this your right? I'm not sure. But we're going to be shading to the right regardless. So I grab my blue pen and we're going to shade to the right. And when I get to the end, I'm going to shade this arrow a little bit so it's kind of bold. There we go. So we're shading to the right. And that's just because X is greater than or equal to 4. Okay. Now for the -10. Which way are we shading for the -10? Let's talk about that. So what's my solution over here? X is less than or equal to -10. So any number that's less than -10 should be shaded. That means we're shading to the left, right? The left. So I'm going to shade from the left of -10. And then when I get to the end, I'm going to shade the left arrow. Perfect. Okay. And that's it. Okay. So notice the answer is going to be diverging. The solutions diverge. They don't meet in the middle, right? Don't meet in the middle. Okay. So what this means is, well, what numbers are part of my solution set? Basically 4 and anything greater than 4. And then -10 and anything that's less than -10. So for example, 5. 5 would be a part of the solution set, right? Because 5 is greater than 4. Also -20. That would be a part of the solution set because -20 is less than -10. But would 0 be a part of the solution? No. 0 isn't shaded, right? So it's not going to be part of our solution for this problem. So that's what a greater than symbol looks like. It's going to be like a diverging sort of graph. Okay. All right. Let's do one more and then we'll call it a day. Okay. One last tip. If you multiply or divide by a negative number, so if you multiply or divide by a negative number, what should you do? You should flip the inequality sign. Remember that? Flip the inequality sign. And you'll see what I mean when we do this next example. Okay? All right. Let's do this one. -2 times the absolute value of x minus 3 is less than or equal to -8. So let's talk about this one. This is the last one we're going to do today. So I have a -2 on the outside. That means I'm multiplying this whole thing by -2. So the absolute value of x minus 3 times -2 is less than or equal to -8. So the first thing to do is I've got to get rid of this -2 because I want to get the absolute value symbol by itself. So what I'm going to do is, since I'm multiplying by -2, I'm going to do the opposite of multiplying. I'm going to be dividing by -2. So let's see what that looks like. We're going to divide both sides by -2. Just like that. So I'm dividing by a negative number. Okay? So based on my tip that I just gave you up here, we're actually going to be flipping this sign before we start. Okay, so what happens? The absolute value of x minus 3 comes down. The -2's cancel out, right? So they're gone. The inequality sign is going to flip because I just divided by a negative number. So now it's a greater than or equal to. And now -8 divided by -2, what would that be? That would be +4. So I got this now. So this has just been flipped. Right? And that only happens when you multiply or divide by a negative number. Okay, so let's solve this one. I'm going to have two different solutions. The first one is everything is going to stay the same. So the x minus 3 is going to come down. I keep the greater than or equal to, and then the 4 is going to stay the same. So everything stays the same for the first part. And then for the second part, the x minus 3 is going to stay the same, but everything else changes. The sign is going to flip, and the 4 is going to become a -4. And those are our two different solutions. Okay? So now let's solve them both for x. I have to add 3 to both sides. Add 3, add 3. So x is greater than or equal to 7. And x is less than or equal to -1. Okay. So those are my two different solutions. Am I going to be using an and or a or? It's based on this, right? Since it's a greater than, I'm going to be using the or, just like last time. See this up here? Or. Okay. So now I got my two different solutions, and let's draw the number line and let's finish this up. Okay, my real number line. I've got, let's put the 0 over here and the -1, and let's put the 7 over here. Okay, so I put my 3 numbers down and I'm ready to put down my dots. Since I got the greater than or equal to, I'm going to be using closed dots. So I'm going to put a closed dot here, a closed dot here, and which directions am I going to shade? Well, for the 7, I got to shade to the right. So I shade to the right. And then from the -1, I'm shading to the left. Shading to the left. And the inequality signs will actually tell you which direction to shade if you kind of look at it, because this one's kind of pointing to the right and this one's kind of pointing to the left. So a little tip you probably already knew, but just to show you, the inequality signs kind of tell you which way to shade. Okay, and that's it. So notice that the solutions diverge because they're going in two opposite directions instead of meeting in the middle like the first one did. But yeah, that's absolute value inequalities.